So we're going to start 5.3, our sum and difference identities. So we are going to introduce 3 new identities today. These are found on your identities paper. They're like close to the top right-hand corner, just underneath the half-angle formulas. So sum and difference. All right. So the first ones we're going to talk about are our trig identities. Our sign, specifically the sign identities. So it says sine of A plus or minus B equals sine of A cosine B plus or minus cosine A sine B. Now, I'm going to say right now the plus or minus doesn't mean the same thing it does in quadratic formula, where it means you have 2 different answers. Here it's just saying that, okay, if it's sine of A plus B, so if we're using the plus right there, we're going to use the plus here. If we use the minus here, we use the minus there. So really it's 2 different identities, one with plus, one with minus. So let's look at how this works. Well, on the blue example, it says we have sine of pi over 2 minus x. So this is my A, this is my B, and notice we have minus. So we're just going to plug into our formula. So we're going to write sine of, our A is pi over 2, cosine of, our B is x. Now because this is minus here, we're going to make sure we use minus here. Cosine of pi over 2, and then sine of x. And because we know what sine of pi over 2 and cosine of pi over 2 are, we're going to simplify this a little bit further. We're going to say that this is, what is that? Sine of pi over 2 is just 1. Cosine of pi over 2 is 0. Well, 1 times cosine of x is cosine of x, and 0 times anything is 0. So cosine minus 0 is just cosine of x, just like that. Let's try this next one. Here we have sine of 5 plus pi. So again, plug in. We have our A plus B. So sine of 5 cosine of pi, and then it's plus, so we're going to use plus cosine of 5 sine of pi. Now, I don't know what sine of 5 and cosine of 5 are. I know they're going to be decimals and not on a unit circle, so we're not going to simplify those. But cosine of pi and sine of pi, we do know those from a unit circle, so let's simplify those. Cosine of pi is negative 1. Sine of pi is 0. Well, 0 times anything is just going to be 0. So it's negative 1 times sine of sine of 5 is going to be negative sine of 5. And then we move to the last one. Well, here we're just going backwards. We're saying what a sine of A plus B would give me this. Well, first, it's a plus sign, so it is going to be a plus. So I'm going to have something plus something, something plus something. Well, what's my A? What's my B? Well, there's my A, there's my B. So it's going to be sine of 5 plus y. All right, well, let's see what it looks like if we're using cosine. So here's cosines, and if you're looking carefully, it might look like I made a typo right there, but I did not. And that's actually what it's supposed to be like, is upside down plus or minus. What that means is we're going to do backwards. So whatever this sign is here, if it's plus here, I use minus, and if it's minus, we're going to use plus. So with cosine, we're going to do the opposite sign. So let's see what that looks like. Also notice here it's just cosine, cosine, sine, sine. That's another way I can tell the difference between the two. So it's cosine of 5 plus x. So I know there's my a, there's my b. So cosine of the first one, the a, cosine of the second one, x. And because it's plus here, I need to do the opposite, minus over here. It's sine 5 sine x. And then, well, what if I try to go backwards? So I have cosine, cosine, sine, sine, so that's how I know it's a cosine one. This is a plus sign here, which means that I have to have a minus sign over here. My a is 5, my b is y. So this is going to be 5 minus y. Alright, and then that brings us to tangent. Tangent may look a little scarier, but it's really not that bad. So notice we do have both sets of signs. So here I have regular plus or minus. In the bottom we have minus positive. So in the top we use the same sign. In the bottom we use opposite. So for example, if we have a plus sign over here, the top is going to be a plus sign, but the bottom is going to be a minus. Okay? So let's look at this first one. Well, the first one we're just going to work backwards. So we're going to say it's tangent of, well, here's my a, here's the sine, here's the b. So it's pi plus, because this is the sign that stays the same, and then 3. Well, what if I try to start off with tangent of something a plus b, or in this case, a minus b, and then get this? Well, we'll say tangent of a, which in this case is x, minus, because we use the same sign, tangent of our b, which is 5, all over 1, and then opposite sign, so plus tangent of a, which is x, tangent of our b, which is 5. And that's what I ended up with. So hopefully those don't seem very difficult, because they're not. They look maybe a little different, but they're actually not that difficult to use. So we're going to see, well, how can I use them to find exact value? Well, whenever I see exact value, that means they want me to use my unit circle. The problem is 195 is not on my unit circle. So I'm going to figure out some values that are on my unit circle that add to make 195. So let's think about this. What adds to make 195? So I'm going to look at my values on my unit circle and think, okay, 195 equals something plus something. And I could use minus as well. I usually don't, because I think addition's easier, but you can use, if you have two numbers that subtract to make 195, that works just as well. So let's start off with 30, our first angle. 30 plus what is 195? Well, if I subtract 30 from 195, I get 165. Well, 165, not on my unit circle, so that didn't work. Alright, let's try a different one. How about the next one on my unit circle? 45. Well, 195 minus 45 is 150. Is 150 on my unit circle? Yes, 150 is on my unit circle, so I can use those two. There are other combinations I could have used. I just needed to find one that worked. So what we're saying is that sine of 195 is the same thing as sine of 45 plus 150. Okay? Now, if I can say that, then I can use the identity of sine that we just finished using. The identity said, well, there's my A, there's my B. So sine is going to be sine of my A, which is 45, cosine of B, which is 150, plus cosine of the A, sine of the B. And using my unit circle, I can figure out what each one of those things are. Sine of 45 is the same thing as cosine of 45. It's square root of 2 over 2. Cosine of 150 is negative square root of 3 over 2. And again, if you're not sure where I'm getting these numbers from, just look on the unit circle. Remember, cosines are x, sine is our y when we're looking at the unit circle. Cosine of 45 is square root of 2 over 2. And then sine of 150 is positive 1/2. Alright, well I can multiply those together, and that gives me negative square root of 6 over 2 plus square root of 2 over 2. And those two things have the same denominator, so I can combine them into one fraction and say this is the square root of, or negative square root of 6 plus square root of 2 all over 2. And that's what the sine of 195 is as an exact value. Oh, all right. I'm dropping stuff. Well, what if we have it in radians instead of degrees? Well, this still works. I have 13 pi over 12, and I'm actually going to ignore the pi for just a second and think of this as just 13 over 12. Well, remember, a fraction is something plus something. I know my denominators both have to be 12. And if you think about this, on your unit circle, none of your denominators are 12. So these two fractions have to simplify. So whatever number I put on top as my numerators have to be able to simplify. And what I mean by that is if I put 1 and 12, that doesn't work because 1 over 12 doesn't simplify. I can't simplify 1 over 12, so that's not going to be on my unit circle. Fortunately, oops, let's use a different color than that. There are a lot of numbers that simplify with 12. So again, 12, something plus 12. So let's think about what adds. There's actually quite a few. For instance, 2, and, not 2. I was thinking of adding to make 12. We're adding to make 13. 3 and 10. 3 plus 10 is 13. 3 over 12 simplifies. 10 over 12 simplifies. I could use 4 and 9. Both of those would simplify as well. 6 and 7 would not. 8 and 5 would not. So, okay, yeah, probably 3 and 10 or 4 and 9 would be one of your two options. So I use 3 and 10, so let's simplify these. Well, 3 over 12 simplifies to be 1 over 4 plus, this is going to give me 5 over 6. Now I'm going to tack my pi back on, and I have 1 pi over 4 and 5 pi over 6. Okay, so over here, sine of pi over 4 plus 5 pi over 6. All right, so there's our sine function. There's two things that we know are on our unit circle. Let's add them together. All right, our sine function says sine of A plus B. So sine of A cosine B plus cosine A sine B. Alright, and then on my unit circle, sine of pi over 4 is square root of 2 over 2. 5 pi over 6 is actually just going to be the same as the last one because it's a 150. So cosine is square root negative square root of 3 over 2. I guess I should use a different one. Cosine of pi over 4 is square root of 2 over 2. Sine of 5 pi over 6 is 1/2. If I multiply, negative square root of 6 over 2 plus square root of 2 over 2. Combine them into one fraction and I get negative square root of 6 plus square root 2. We're going to skip ahead a little bit to number 9. So on number 9, we need to figure out, well, which identity is this? Is this the sine, is this the cosine, or is this the tangent? Well, the dead giveaway on this one is that there are two cosines together and then two sines together. That means this one has to be the cosine one. For sine, I have sine, cosine, cosine, sine. And of course, tangent's a fraction. So that's how I know this one is cosine of something. Because it's cosine of something, I'm going to do the opposite of that sign. So minus. Well, what's my A and what is the B? Well, there's my A, there's my B. So my A is negative 2 theta. The B is 3 theta. And then I'm going to think, well, negative 2 theta minus 3 theta. Well, negative 2 minus 3 is negative 5 theta. And circle it. That's all I'm going to do right there. Okay, hopefully that seemed fairly simple. Next one I want to do is number 15. Alright, so for this one, we're still doing pretty much the same thing. Technically, this is a proof, a verify. This is not an equation, so this is kind of like what we did in the last section, 5.2. Except this is the most straightforward proof you're really going to see. When I see this, they're telling me they want me to use my sum and difference. And so I'm trying to get this to look like that. Well, here's my A, here's my B. Let's use our tangent identity. Our tangent identity is tangent of A plus tangent of 135 all over one opposite sign, so minus tangent A, which is theta, tangent B, which is 135. Well, 135 is on my unit circle, tangent's not, but 135, sine and cosine are the same value. Cosine is negative square root of 2 over 2, sine, and sine's positive. So for instance, so tangent 135 is equal to sine of 135 over cosine 135. And on my unit circle, I see that that's square root of 2 over 2 over negative square root of 2 over 2. Well, whenever I have a number divided by itself, the answer is 1, and a positive divided by a negative is a negative. So tangent of 135 is just negative 1. So I'm going to substitute that in. I'm going to say, well, that's tangent of theta. So plus negative 1 is just minus 1. And then 1. And so tangent of 135. So tangent of 135 is negative 1. Negative times already a minus makes that going to be plus tangent theta. And so now this and this are the same. So sign your proof. And that's the last one. So good luck with the rest of those. And I'll see you on the next section.